What is up? What is up? What is up? Oh no! I just dropped a frame. Hasn't dropped a frame in like 10 minutes. Where's everybody? Are you guys out there? Hey, where's everybody? Oh yeah, we're doing virtual, I forgot. Come on, let's go. Come on, hey, let's round out the week, guys. Let's round out the week. Round out the week. Hope you guys are having a great Friday. Hope you guys enjoyed your first hour. I kind of have a lot for you guys today, so I'm going to really need you guys. And I know I'm putting a lot on you pretty early here. I know I'm putting a lot on you, but it's all to help you, right? Like the big concepts, the 40 to 60% of the AP tests, and just general the more interesting stuff. That's the stuff I want to allocate more time to, right? Our time is scarce, right? And if I allocate too much time to Unit 1, the opportunity cost is Unit 3, Unit 4, those big units. Yes, we got to get the chat going today. Like no one was talking yesterday. Remember, be appropriate though. All right, so let's go ahead. Hey, throw attendance in the chat so I can just command find it later on. Stand up. You want to see if I'm wearing shorts? Are you trying to see if I'm wearing shorts? I'm not wearing shorts. I'm not wearing shoes or anything, but I got pants on. All right. Jeez. Hey, Michael, why don't you go ahead and go do 10 pull-ups real quick on that pull-up bar, and then talk to me. All right. Yeah, go ahead and put attendance in the chat, and then also part of your attendance today, I was wondering if you guys would do this. Write one positive you've had from this experience this week, and it doesn't have to be my class, just being back at school, you know, how this looks like now. What is one positive, you've felt during this week, right? Some of you guys are loving it. Some of you guys are really disliking learning virtually, but just put like one positive you've experienced this week, and it can be in any class. It doesn't have to be in my class or anything like that. That's also part of your attendance. I'm going to read that later. Okay, I might read some now, but I want to make sure you guys all did that later. Again, if you're having any YouTube channels or YouTube problems and talking in the chat, make sure you Jupiter message me. I don't want to mark you absent just because you can't get on. Okay, I appreciate that, Dylan. You're the GOAT. Okay. Am I ready to go? Oh yeah, I have some reminders for you guys that I wanted to talk about. So first thing is that I haven't really formally, and I should have talked more about how problem sets are going to work. Problem sets are going to work like this, right? So I gave you guys problem set 1.1 yesterday. That is not due at the start of class today. I want to give you guys an opportunity, if you're really struggling with the problem set, to ask me about that problem set in the Google Meet, twice over, right? So if you have not completed problem set 1.1 tonight, I don't want you rushing to do it before class today. I want to give you another opportunity in another Google Meet, so I can clarify questions, right? So basically, you get 24 hours plus it's due the following midnight, okay? So that's how problem sets are going to work. Also, I've had a few students reach out to me and they said, how do problem sets work, right? Are you grading it for correctness or completion, all right? Basically completion, right? But if it becomes a problem where I notice that you're just putting bogus answers in there, then we're gonna have a problem, right? And then I'll start taking points off and etc. But the problem sets, you're supposed to be making mistakes on the problem sets, right? You should not by any means be becoming frustrated that you're getting a bunch wrong. That's fine. You should be getting some wrong on the problem sets. The first time you've ever worked with any of that content, right? But the most important thing from doing the problem sets is when I post the answer key, which I'll post the answer key tomorrow, and I'm also going to post the Unit 1 note, or not the Unit 1, but the Basic Economic Concepts notes from yesterday, also tomorrow. Because I don't want to post it yet because it actually has the answers on there, and I don't want to delete them because then I'll lose them, and I don't know. But everything's going to be posted tomorrow. If you really want to, re-look at the PowerPoint without watching the video, or you want to look at your answer key, okay? A lot of you guys are saying less homework. I've had a few students say they get more homework, but I guess you only have 3 classes, so that's pretty nice. Hopefully I'm not adding to your homework load like crazy. And believe me, things are going to slow down, right? But I'm just like if we were in class, I want to power through this Unit 1 stuff. Now, I don't think the lecture is going to go as long today than it went yesterday. Yesterday went pretty long. But today's very, very important. Today's your first graph that you've learned in AP Macroeconomics, the production possibilities curve. So you got to be on your game. Last reminder before we get into it is make sure you have a sheet of paper to write on, because we're gonna do some practice at the end of the live stream. We're still gonna stay on YouTube for a little bit of practice, right? I'm gonna give you 5 minutes. You guys are gonna draw some graphs and answer some questions, and then we're gonna go over it. And then at that point, we're gonna transition to Google Meet. Okay. Sweet. That's pretty much all I wanted to cover. I'm pretty sure. Okay. So let's move over to here. You guys all got your coffee. We had the coffee talk yesterday. It's a really, really important thing. Because if you're not getting enough sleep, you might have to get a little caffeine in your life. Okay? All right. Well, let me just look through some of these responses real quick. Less homework. People, a lot of you guys are saying only 3 classes. I'm liking the same thing too. I can allocate more time to just you guys, right? Which is pretty cool. Oftentimes in a normal classroom setting, I really walk around, glance through problem sets, give credit really quick. My micro problem sets this morning, I looked at everyone's problem set, and I graded that like crazy. Now I gave them 100%. They looks like they tried, but I'm really able now to identify which students are really struggling in this setting, which is really cool. No, you don't. You're not. That's a good question, Allison. You do not need graphing paper ever in this class. Graphs are always going to be very, very generic. In this class, we're never even going to put numbers on our graph, if that makes any sense. Right? You just need an X and a Y, label both sides, have curves on there, and we're just going to move them around. Right? So that's a good question, but we'll never use graph paper ever in this class. You can just use a random sheet of paper here. Some of you guys saying be more productive. structure to my day. I'm really appreciating that as well. And I want to thank you guys for that too, right? Like this, other than Tuesday, but after Tuesday, like I've really appreciated some level of normalcy in my life. I've really appreciated having some sort of goal and being able to work towards a goal. I haven't experienced that since like March. So this is pretty cool, I would say. All right. Anyway, moving on. Let's get into this, right? Quicker we get into this, the more time you guys will have to finish 1.1 if you've not done so, and to work on 1.2. The longer we can chill out and see one another and hang out, and I can answer any questions that you guys got. All right, so remember, problem set 1.1. A lot of you guys maybe have struggled on this, right? But like again, if you're kind of like, I don't know if like, Mr. Moore talked a lot yesterday, talked for like an hour. I don't know if I'm like, I know all the information that I need to know. If you can do this FRQ really well, like you're doing great right now. You're doing great right now. And even if you get 4 out of the 5, I'm very, very pleased with that. Okay? All right, anyway. Moving on. All right, so today's focus, more general, is going to be production. Right? We're going to be really focused on production, producing stuff. How are things produced? And how can we increase production capability, right? Production. That's the most important thing, okay? As our economic concept, we're going to use a graph. And this graph that we're going to learn about, we're going to tie a lot of things that we learned about yesterday into the graph, right? So you guys learned about opportunity cost and marginal analysis and efficiency and trade-off and scarcity. We're going to see all those on the graph. All right, besides marginal analysis, we're not going to see marginal analysis on the graph. I don't know why I said that. All right, so production terms. This slide is so important, people. So important. I'm going to talk about one word specifically here, and some students never understand it, and it really, really hurts them in later units. So make sure you guys are getting these terms. Also, I really, really hope you guys got your textbook yesterday. I really hope you guys got your textbook. Right now, we're through Module 1. We skipped Module 2 because we're going to do that in Unit 2, Method of Madness. Module 3 is this, right? And then if you really want to, Monday's content sometimes is tough for students. Now, generally, it's the highest quiz I ever give, generally. But comparative advantage sometimes gets some students because it gets really mathy, right? So if you want to leg up on Monday's lesson, I would heavily encourage you to read Module 4 over the weekend, okay? Alrighty, let's get into it. So the first term I want to talk about, or terms I want to talk about, is price versus cost. Because generally in our everyday lives, we use both of these words interchangeably, right? Like, I went to the store and the price was this, or it cost me this much. In economics, we need to be a little bit more precise. Economics is all about precision. Price is how much the consumer pays for the product. In other words, price is the price tag, right? So like if you go to the grocery store, you buy some burgers or whatever, right? The price you pay for the burger is the price, right? Generally, I think we use price appropriately. Cost, however, is how much the producer paid in order to produce the product. Super important, right? A seller doesn't pay a price. A seller pays a cost to produce it and then sells that item, that good or service, for a price, okay? Pretty simple, I hope, but we need to make sure we use those words correctly, okay? Because we're going to need to later on. The second word is the most important word, and this is the word I was talking about earlier, is investment. What does investment mean in economics? Investment is not buying stocks, not buying bonds, not buying mutual funds. It's not putting money into your bank, not putting money into a savings account, or anything like that. It's not investing, how we generally use the word investing. Investment in this class is very, very specific. Investment in macroeconomics has everything to do with businesses spending money on capital goods. And I'm going to talk more about what capital goods are in a second. But it's this idea that businesses generally take out a loan. And when they take out that loan, they go and take that money and they upgrade their production process, right? Like they'll buy new computers, right? Or they'll spend money on training for their employees. They'll buy a new warehouse. They'll buy new robots, right? They'll buy new shipping containers. They'll buy new delivery trucks, right? You guys saw Domino's has heavily invested in the last few years. Domino's looks entirely different than Domino's looked like 10 years ago. Their app, they got like crazy delivery vehicles now in some cities. Just all new advertising, right? That's the idea of investment. A business generally takes out a loan and invest it because they think that they can make more money in the future, pay off that loan, and double the revenue, right? In hopes to double their profit. That's the idea of investment. So like whenever you hear the word investment, please, please, please always be thinking about businesses. I cannot stress how important this term is enough, all right? So like an example would be like a business spending $1 million in a new factory. Okay, that's what investment is. It's never going to be people investing in the stock market or anything like that. All right, the next two items are very, very important as well. There's two different goods in this world, because we're going to, in a second here, we're going to be talking about production, and we're going to talk about producing goods and services, but really more so focused on goods, right? Something that we can touch as a good. Service is something that like someone does for us. We have consumer goods in this world, and we have capital goods. All right, consumer goods are goods that are made for direct consumption. All right, it's a good that is produced, and then it's sold to a consumer, and then the consumer buys it, and then like that's it. All right, that's the end of it. All right, so like using like a pizza restaurant for example, the consumer goods that a pizza restaurant produces would be, pizza, calzones, breadsticks, soda, things like that. Right, those are consumer goods. Very, very important. A capital good, however, is a good that a business produces, and then that good is sold and used by another business. All right? So a capital good would be like a pizza oven, right? Some business made a pizza oven, and that's a capital good because a business is going to buy that item, not a consumer, and that business is going to use that item to make consumer goods. So essentially, capital goods make consumer goods. Super, super important. Capital goods make consumer goods. A capital good is a good that is produced, is purchased by a business, and then it is used to make consumer goods. All right, so like it's the pizza oven at the Domino's. Okay, the consumer good is the pizza that Domino's produces. Okay. All right, I hope you guys are tracking on that one. Pretty good, pretty good. If you got questions, remember, throw it in the chat. All right, please, please, please throw questions in the chat. Right, that's like the one negative in my eyes about YouTube Live. One, there's like a 20-second delay, but like I need a little bit more feedback from you guys that I generally would get in a normal classroom setting, right? And if I don't answer your question right, then Google Meet's a good time for that. Absolutely. All right, next up, we're going to talk about the factors of production, the 4 factors of production. Factors in economics is a synonym for resources, right? So if you ever see factors, it means resources, okay? So what we're going to talk about are what are the 4 resources, what are the 4 ingredients that you need in order to produce a good or a service. So all economists believe that you have to have all 4 of these items in order to produce anything. Okay, you have to have all 4, or else you can't produce a thing. So the first ingredient that we need, the first resource, the first factor that we need is land. All right, so what is land? Land is 2 things. Land is land, right? The physical space, right? And any sort of business has to have physical area, space in order to produce a good, right? So let's pretend that we're making tires, right? In order to make tires, we need a room, right? We need a building. We need space. Okay, that is land. Not the building. Don't let me get confused. The building's not land, but like the area that the building is on is land. But more importantly than that, land is the raw materials, right? So if we're making tires, a raw material would be like rubber. Okay, that's pretty much like the only thing that'd be used. We might use water to make tires, right? Maybe to like cool it, like mold the rubber. I don't really know how tires are made, but any sort of raw material that's used to make tires would be like rubber for the most part. Maybe we're making cars, right? So if we're making cars, it would be rubber for the tires, steel, glass for the windows, probably some plastics, right? That's all land. Okay, it's kind of weird. Like that's called land in economics. Okay. So we need land, right? So we got physical space, and I give us a bunch of steel, glass, rubber, and plastic, right? Can we make a good yet? Can we produce anything yet? Absolutely not, right? We just have a bunch of raw material sitting in like a space, okay? Number 2, what we need is we need labor, right? That's pretty simple, right? We need people in order to do work. Now, steadily over time, labor in order to produce goods is generally being replaced by automation, right? By robots. Generally, I show a video of Amazon, and maybe I'll show it on the Google Meet. But I believe the average amount there's human contact with an Amazon package is like 60 seconds, right? So when you purchase a product from Amazon and you receive it, humans only touch that for about 60 seconds. All right, automation is definitely heavily replacing labor, but in general, we still need laborers, right? Laborers. We still need people that do the work. Okay, so far, we got physical space with raw material, right? Steel and plastic and rubber and whatnot. And then I put people next to it, right? Can we make a car yet? We can't make a car yet, right? We need more stuff, right? We can't just have people next to raw materials. They don't know what to do, and they need tools, okay? So capital. There's many different forms of capital. One thing on here that's not written on here is financial capital. Generally, a business needs money, right, in order to buy the resources in the first place. That's called financial capital. We're not really going to be so focused on that. Physical capital is machines and tools, right? Like in order for you to produce a car, you need some pretty heavy machinery, right? You need to be able to mold that tire, that rubber into a tire. You need to be able to mold that steel into like a car frame. Make that glass a windshield, right? You need tools in order to piece things together. That's called physical capital, the tools and machines that we use in order to produce goods. The third type of capital is called human capital. Human capital is the know-how. It's the education. It's the knowledge in order to produce something, right? So what do we have so far? We have land, right? We have physical space with rubber, steel, all the works, right? I put people next to it, but they don't really know what to do. But then I give them knowledge. I give them know-how. I say, like, here, you put the rubber in this machine, out spits a tire, right? So they need to know what to do, how much rubber to put in. They need a machine in order to put the rubber in there to make a tire, to produce a good. Now, some of you guys are like, I think we have everything that we need in order to produce a good, right? Well, we're missing one last thing. We need an entrepreneur, right? We need someone to run the production process. We need a leader. We need someone that's saying, hey, we need to make X amount of cars and ship them to this vendor or whatever, right? We need to make the car look like this because this is what's going to sell. A bunch of decisions. We need to advertise in order to get people to know of our product, right? We need someone that ties all these factors of production together. An entrepreneur, right? Like a Henry Ford, Bill Gates, Steve Jobs, someone like that, or just like a local business person, right? So that is the 4 factors of production. Very, very important, all right? The 4 factors of production. So when we get to talking about what could increase production, we need an increase in one of these 4. If we don't have more resources, we can't produce more goods. Okay? All right. Moving on. Well, hey, one in the chat if you're tracking right now. You're picking up what I'm throwing down. Uh-oh. Did my stuff freeze? You're picking up what I'm throwing down. One in the chat. If you're here, you're not sleeping. Okay? Next up, we're not going to do this warm-up, right? But I just want to look at it real quick, okay? Say you are working at a pizza restaurant and you open up your refrigerator and all the ingredients in order to make a pizza or a calzone are in there, and you notice you have enough ingredients to produce these production possibilities here, okay? You have enough ingredients in your freezer to make 4 calzones, but if you make 4 calzones, you're going to have no resources left over to make pizza. If you choose to make a pizza, notice that you're going to have to forego the opportunity of making a calzone. The more and more pizza you decide to produce, you're going to have to move resources away from the production of calzones into the production of pizza. Okay? This is the idea of production possibilities, right? This is our capabilities right now. Right now we have 5 combinations that we could choose to produce. We could choose combination A, B, C, D, and E. So you're aware, right, or you can see that this is where we're going to start talking about opportunity costs, right? If I choose to produce 4 pizzas, the opportunity cost is producing calzones, right? If I was thinking about producing 4 calzones and 0 pizzas, and I said and went, it made 4 pizzas and 0 calzones, the cost of making those 4 pizzas is 4 calzones. That's what I gave up, right? That's the idea of opportunity cost. The next best alternative, the next choice you would have done is your opportunity cost. But let's let's put a table on there again. Then we're going to graph the table, and then we're going to make generalizations. And that's sort of the step, the methodology of economics. And don't write this down right here, but like generally we're going to learn about a few graphs. I think like 6 or 7 in this class. And generally when we learn about a graph, step 1 is explain using words, right? Kind of like I just did there, right? We're going to make pizzas and calzones. We only have so many resources. We're going to have to choose which combinations we're going to be able to produce. When we make more of one good, obviously we're going to have to move resources away from another good in order to produce that good. Step 2 is use numbers. I kind of just did that, but I want to do it again here in a second. And then we're going to take those numbers, plot it onto a graph, and then afterwards we're going to make generalizations using the graph on how the world works, right? Kind of like when I was talking yesterday about monetary policy, how it can reduce unemployment by using those 3 graphs, right? Okay. So what is a production possibilities curve? Or sometimes it's called a production possibilities frontier, right? Like think about like the frontier, like westward expansion in the U.S., right? Like the frontier was like as far as people like explored, if you will. So a PPC or a PPF is basically all the different ways an economy, a business, or maybe a person can produce goods using scarce resources. Okay, so the reason we're gonna learn about this now is it ties in everything that we just learned about yesterday, right? Scarcity, efficiency, opportunity cost, trade-off, all those big key concepts. All right, we're gonna have to maintain these key assumptions though. However, you're gonna hear me say the word ceteris paribus a lot. It's Latin for all else equal, but really to me it means don't think so much. Like we need to when we look at graphs in economics, we're gonna keep it insanely simplified, right? We're not trying to graph the world. We're trying to graph a concept and then use that small concept to make generalizations on how the world is, okay? So whenever we're using a PPC, we're only going to use 2 goods, right? Obviously, you know, Domino's Pizza makes more than 2 goods, right? Obviously, most businesses make more than 2 goods. But we're going to use 2 goods because it's going to make it very, very simple. And we're just using that to explore a concept or multiple concepts. We're going to assume that the curve, the frontier, the line you're about to see on the graph, represents full employment of resources. Insanely important. That line represents how much we can produce at if nothing goes to waste. We use everything. We use all of our time, our labor, our land, all of our tools appropriately. That's the curve that represents our production capabilities, right? If we're using all of our resources to the best of our ability. We're going to assume that the curve represents a snapshot in time. We're going to assume that at the current moment, resources are fixed. Now, obviously, businesses they try to get more and more resources so their capabilities of producing would expand over time. But we're going to assume that curve represents a snapshot in time. And last but not least, same thing with technology. Obviously, most businesses increase technology over time. We're going to assume that technology is fixed at a given moment, and if technology changes, then we'll make some changes to our graph. And we'll talk about that at the end of the live stream. All right, anyway, so here is another table, kind of like the pizza and calzones I just showed you, but now we're producing 2 different goods. We're producing bikes and computers, right? So let's look at a couple things here. If we allocate, remember allocate means distribute. If we distribute all of our resources in the production of bikes, how many bikes can we make? How many bikes can we make? If we use all of our resources to make bikes, how many bikes can we make? Here we can see it's 14 bikes, and I know our max capacity of bike production is 14 because when in doing so we produce 0 computers, right? When we make 14 bikes, there's no resources left over in order to make any computers. Like all laborers are fully making bikes. We use all the steel and plastic to make the bikes. There's nothing left over to make any computers, right? Same thing for computers. If we allocate all of our resources, thank you, Luke, to make computers, right? How many computers can we make? It'd be 8 computers. If we use all of our resources to make computers, it's called specialization. Another term. Econ's full of terms, right? That's why I really want you guys to explore that textbook. I don't have time to I'm not gonna assign vocab to you guys, right? We just don't have time for that. But definitely you can find it in the textbook. I mean, these words are, kind of out of hand. Anyway, computers, right? We can make up to 8 computers. If we do so, we'll have no resources left over to make any bikes. And then obviously, if we want to make some sort of combination of bikes and computers, if we make 2 computers, we can only have enough resources left over to make 12 bikes. If we want to make more computers, oh, hey, look what I learned last night. Watch this. I got a laser pointer. Isn't that pretty sweet? If we choose to make more computers, we have to forego more bikes. Every time we choose to make a computer, we have to give up more and more bikes. Vice versa, every time we choose to make more bikes, we have to give up more and more computers, right? Can we right now make 14 bikes and also at the same time make 8 computers? Absolutely not, right? We don't have enough resources to make 14 bikes and also make 8 computers. If we want to make 8 computers, we can't make any bikes. If we want to make 14 bikes, we can't produce any computers, right? So hopefully you guys can see opportunity cost and trade-off here. When we make a choice, we have to choose not to produce something else. All right? So let's put it on a graph. Let's go ahead and put this on a graph. Let's see what a PPC or a PPF actually looks like here, right? So there's the numbers. I'm going to plot each point. Remember, if we specialize, and I'm going to start using that word a little bit more here because it's going to come into play more on Monday when we learn about comparative and absolute advantage. If we specialize and only produce one thing, that's what specialization means, we can only make 14 bikes, but if we do so, we have no resources left over to make any sort of computers. And then as we move resources away from the production of bikes into the production of computers, we're obviously going to be able to make more computers, but we're going to give up the opportunity of making more and more bikes. We want to make more and more computers, we're going to have to give up more and more bike production, all the way until if we specialize in the production of computers, we're not going to be able to make any bikes. We'd be producing 0 bikes. Draw a line through that. That is that frontier I was talking about. That is the curve. That curve represents there the full employment of resources. If we're using all of our labor, our land, everything, we can produce any of those combinations, A, B, C, D, and E. Okay, and I'm sure we can produce some sort of other combination here. We can produce like 7 computers and like 2.5 bikes-ish. Okay, that's the production possibility curve. So here's some big concepts here. Any point inside the curve, right? If I put a point here, that point represents inefficiency. If you're taking notes, I would just draw it without numbers on here, put a point inside your curve, and that represents inefficiency, or when we get to macroeconomics more so, unemployment, right? Because unemployment means we're not using all of our labor, right? So if we have any sort of level of unemployment, we have to be inside this curve, right? For example, if we produce right here a combination of 8 bikes and 2 computers, see how this would be a combination right here? We're not being efficient, right? If we produce 8 bikes, we have more resources left over to make more than 2 computers. If we produce 8 bikes, we should have enough resources left over to make about 4 computers, right? So any sort of point inside this curve always represents inefficiency. Here's the big concept. Efficiency in economics is how well we use the resources that we have, right? So if we're inefficient, it means we have the resources necessary, we're just not using them, okay? That's what efficiency means in economics. Productivity means something a little differently, but I'm going to wait on that here in a second, okay? Efficiency is how well we use our resources. Efficiency is not the same as productivity. I'll cover now. Productivity is our capability of producing, right? Our productivity is represented by this frontier, this line. If we have an increase in productivity, we have to move the line. Right? That means we're now capable of producing more stuff, right? If we have an increase in productivity. The only thing that's going to cause an increase in productivity is more resources, okay? So anyway, a point inside this curve represents inefficiency, anywhere inside this curve. Any point on the curve, E, D, C, B, and A, represents efficiency, right? Max efficiency. If we're operating at any of those production combinations, A, B, C, D, or E, we're operating at 100% efficiency. We're using all of our resources because that's what that curve represents, full employment of resources. Last but not least, any point outside the curve, to the right of the curve, represents an impossible or unattainable combination at this given time. Now, at some point, we may be able to produce that combination G, but that would require an increase in productivity, which would require an increase in resources. But right now, we do not have enough resources to make 7 computers and at the same time also have enough resources left to make 11 bikes. It's impossible. Right? We can get there at some point, but right now it's impossible. Okay? I can't stress how important that slide was for you guys. Very, very important. right? If I say, draw and label a point that is inefficient, it better be inside the curve. If I say, identify a point that is efficient, it has to be some sort of point on the curve. Identify an impossible point, it has to be outside the curve. Okay? Moving on to another very, very important slide here. Time check, 11:30. We're gonna do great. We got this, people. We're doing great. Okay, we learned about opportunity cost yesterday, right? Opportunity cost means it's what you give up. It's the cost of what you give up when you choose to do something else. It's that next best choice. So we can measure opportunity cost if we have a next best alternative. So question number 1 here says the opportunity cost of moving from point A to point B is what? So what that means is this firm decided to produce that combination B. They were thinking about producing that combination A, but they chose to go with combination B. So what is the cost of producing at combination B, right? What is the cost of producing 2 computers and 12 bikes? Well, when they went from A to B, in order to make 2 more computers, they had to give up 2 bicycles, right? So the answer is 2 bicycles, 2 bikes. Okay? I'm going to do 2, and then I'm going to ask you guys to do 3 and 4 here. The opportunity cost of moving from point B to point D is what? All right, so if we go from point B to point D, we chose to produce at point D, we were thinking about producing at point B, so in choosing to make how many more computers? We chose to make 4 more computers. We gave up the opportunity of going from 12 to 5, so 7. In producing D instead of B, we chose to make 4 more computers, so we gave up the opportunity of making 7 bikes. Okay? I want you guys to do 3 and 4, right? So like number 3 is this and number 4 is this, real quick. I want you guys to try to do number 3 and number 4. Let's get a little interaction here a little bit. And shoot, you could probably do number 5 in a second, I would imagine. Should be real easy. What is number 3 and what's number 4? Make sure you put like 3 dot, whatever. I need some formative assessment here, people. I need to see if you got this. I'm working with a stream delay here. What is the opportunity cost of producing at B when we were thinking about producing D? We chose to make more of what, so we gave up more of what other good? In a few seconds here, the chat's going to be popping off here. Come on. And people, don't be embarrassed if you get it wrong. You just learned about it like 20 seconds ago, right? You're not expected to know this. You're not expected to. That's why I want to see if you know it. Because I know a lot of you guys don't know it, right? That's the idea. My man Kyle, look at him. My man. Yes. Zaid. Dylan, a guru like his brother before him. Aiden, yes. Kyle, John, Maddie, Lydia. There we go. Good job, guys. Adonis, is that how you say your name? I need to go look at the flip grid. I don't want to say anyone's name incorrectly. It's really important to me. Adonis, Annabeth. Son, Luke, Avery, Allison. I don't know if Allison, you want to go by Allie or Allison. I can't remember. Then we got Madeline and Madeline. I don't know which one wants to go by Maddie. I got to do better, people. I got to learn your names a little bit better here. Awesome, people. I love it. So yeah, definitely. Number 3 is 4 computers. Why is number 3 4 computers? When we go from D to B, right, we chose to make 7 more bicycles, right? We went from 5 bicycles to 12 bicycles. So in doing so, we had to give up those 4 computers, right? We're moving right to left instead of left to right along our curve. Now, F to C is really hard, right? F to C is kind of tough, right? So like if you got this one wrong, not a big deal. Number 4 is this. If we go from producing 6 bicycles and 4 computers to instead making 4 computers and 9 bicycles, what is the opportunity cost? The opportunity cost is 0, is none. There you go, Dylan. That's what I'm talking about. It's nothing, right? We chose to make 3 more bicycles, and we didn't have to give up anything because we went from an inefficient point to an efficient point. If we're going from an inefficient point to an efficient point, we weren't using all of our resources. So therefore, we didn't have to give up anything. There was no opportunity cost, right? We just used more of our resources. So the opportunity cost is 0 computers. We didn't have to give up anything if we're going from some sort of inefficient point to an efficient point. And lastly, 5 is unattainable. It's impossible, right? We can't right now produce this many computers and bicycles. Our frontier is as far as we can go. Here's our production possibilities or our capabilities. G is quite simply impossible, unattainable. I love you guys. You guys are doing awesome. Awesome, awesome, awesome. Great answers in the chat. I love it. I love it. I love it. I love it. The possibilities are endless in this class if you guys participate like that. Okay, anyway. Econ puns. There we go. We got calzones and pizzas. That's the same example I gave you guys earlier. What I want to do next is explore the difference between increasing opportunity costs and constant opportunity costs. Super, super important, right? And how a production possibility curve may look. If the frontier is linear or it's curved or bowed out. A lot of people like to refer to. So let's think about this. What is the opportunity cost of moving from point A to point B? If we go from point A to point B, we give up how many calzones? If we want to make 1 pizza, we give up 1 calzone. If we want to go from B to C, we want to make another pizza, we're going to give up exactly 1 calzone. If we go this way, if we want to make 1 calzone, we give up 1 pizza. Excuse me. This right here is called constant opportunity cost. Because as we move left to right or right to left along our curve, opportunity cost is constant. If you want to make a pizza, you give up a calzone. If you want to make a calzone, you give up a pizza. It's exactly a 1-to-1 ratio. Okay? Why would this ever happen in real life? Why would a firm ever experience constant opportunity costs? Or realistically, a firm probably never would experience constant opportunity costs. Because can you think of 2 goods that would use the exact same resources? And that's what's going on here. It's going to cause a straight line PPC because resources are adaptable. I should have, here, 1 second here. I need to make this word a different color because that word is very, very important. Adaptable, okay? Or suitable, or substitutable. You're going to see either of those 3 words, right? Resources are the same. They're adaptable. In other words, like the same resources that are used to make calzones are the same resources used to make pizza. Everything. Pizza takes 10 minutes to cook, so does a calzone. Pizza takes 2 people to make it, so does a calzone. Takes the amount of sauce, cheese, breading, everything, okay? That's the idea of adaptable goods, or sorry, adaptable resources. It's going to cause constant opportunity costs to occur. And when we have constant opportunity costs, when we look at our production possibility curve, it's going to be a straight line, right? The slope would be 1. It's a 1-to-1 ratio, okay? That's the idea of constant opportunity costs. It's when the resources have to be the same. A pizza and a calzone basically is the same thing, right? Basically the same thing. It requires the same factors of production, exactly, right? In this example. Probably not in real life, but let's use 2 different goods and explore a different concept. Let's say this business either makes pizza or they make robots or they make a combination of both, right? A pretty weird business, I would imagine, but they make both things, robots and pizzas. You can see here that, or you can think about, robots and pizza is not the same thing. In other words, they don't use the same resources. There's nothing that is used in the production of a pizza that also is probably used in the production of a robot, other than maybe like labor, right? Right, like robots like metal and steel. Pizza's like sauce and like, jalapenos, right? Good, okay? So when that happens, let's look at what occurs here. So if we choose to make a robot, when we choose to make that first robot, we only give up 1 pizza, right? Maybe one of our workers is like an engineer and like he kind of has it himself, right? He or she knows how to make that robot just himself, right? Then when we choose to make another robot, the opportunity cost is actually greater. As we choose to make another robot, we have to pull more resources from the production of pizza in order to make that next robot, right? Maybe that engineer has to coach 2 high school students on how to make a robot, right? So the production of that second robot is a little bit less efficient than the production of that first robot. And then as we make another robot, we got to pull even more resources away from the production of pizza. All the way until we make 4 robots, we're not going to have any resources in order to make any pizza. Think about a more realistic example. Think about, you guys all had U.S. history last year. Think about World War II, right? A lot of men went to war in Europe, and people got moved around here in the U.S., right? Women entered the workforce in huge numbers. But also, in general, people got moved around, right? You had teachers becoming tank manufacturers, right? You had Henry Ford, making, airplanes, right? You had, people that aren't suited to make something, and you had to pull more and more resources to make another fighter plane, right? So think about, in order to make the 200th fighter plane in World War II, it was a lot more costly than making that first fighter plane in World War II, right? Because we had to take all these other resources away from the production of something else that they're probably good at and train them to produce something additionally that they're probably not that good at producing, right? That's the idea of increasing opportunity costs. As you want to make more and more of another good, it's going to be more and more costly, right? That's the idea. So it's a little bit more realistic, right? Most firms would probably have increasing opportunity costs. So when does this happen? It happens when the resources used to produce both goods are different. That's the idea. Unadaptable goods, unsuitable goods, unsubstitutable goods. There's nothing in pizza that is used also to produce robots. So when this happens, it's going to cause a bowed out PPC. It's going to look curved. It's going to look curved. I'm going to show you a good illustration here on the next slide. Some of you guys are taking notes, and I'll give you guys a second here. We're almost done, people. All we have left is to talk about efficiency, and then we're going to talk about shifting the production possibility curve. And I'm going to end it right at noon. I won't go over, I promise you. Okay, moving on here. All right, so let's look at the difference here, right? We just talked about constant versus increasing opportunity costs. Constant opportunity cost is going to occur when we're looking at two goods and the resources used to produce both those goods are exactly the same, right? So like wheat and corn, both grown in like the Midwest / like Iowa, Nebraska, I would imagine. I'm not really a scholar on like agriculture that much, even though I grow like a lot of peppers. Probably use like the same amount of like water, same amount of like sunlight's necessary, same amount of like land's probably necessary, same amount of like farm equipment's necessary. Let's just imagine that if you wanted to produce 1 unit of corn, you have to give up a unit of wheat. If you want to produce a unit of wheat, you give up a unit of corn, right? Constant opportunity cost. Cactus and pineapple is a little bit different, right? One resource that's very different in one production of cactus and pineapples would be like water, right? Obviously, pineapples need a lot of water, right? It's a tropical fruit. Cacti or cactus don't need much water at all, right? It's a desert plant. So as we make more and more pineapples, it's going to get more and more costly. We're going to have to give up more and more cactus. All the way to make that last pineapple, we're going to have to give up like all of our cactus, right? We could have like 100 cacti plants. I don't even know if I'm saying this right. Cacti plants. 100 plants could survive off just like the amount of water usage that maybe one pineapple would require in order to produce a pineapple, right? Because this is going to cause increasing opportunity costs. The resource water is different in the production of cactus and pineapples. Pineapples need more and more water to produce additional pineapple. To produce additional cactus, you don't need as much water. So it's gonna be bowed out. See how it's like curved, bowed out. So if I give you a PPC that looks like this, and I say which of the following is true, you have to tell me this. One, it's illustrating increase in opportunity costs, and the reason it's illustrating increase in opportunity costs is the goods are unadaptable. The goods are different. The resources, not the goods, the resources are different in the production of both goods. This one's linear, right? It's a straight line PPC, so it must be constant opportunity costs, and the resources used to produce both goods must be the same. Okay? All right. Let's talk about efficiency. Another thing that you need to know, another thing that was on that board, right, in my opening scene. There's two types of efficiency. We said that efficiency is any point on the curve, right? Any point on the curve. Productive efficiency is any point on the curve, all right? To be productively efficient means that we're producing on the curve, quite simply. So like, how do you find it? Any point on that frontier, any point on the curve, right? It's any of these yellow dots. Any of these yellow dots represent productive efficiency. Remember, efficiency is how well we use our resources, okay? Allocative efficiency is a little bit different. It's a little bit more narrow, right? Think about productive efficiency as like a rectangle. Allocated efficiency is more like a square. Like a square is a rectangle, but rectangle's on a square, right? You can be productively efficient, but it doesn't necessarily mean you're allocatively efficient. If you're allocatively efficient, you're also productively efficient. So what do I mean by that? To be allocatively efficient means you have to be on the curve, right? You have to be producing on the curve. You have to be efficient with your use of resources. However, there's another layer to it. You have to be producing in a manner that is what is socially optimal, is what society wants. Okay? The optimal point on the PPC that depends on the desires of society. I'm going to show you what that looks like here in a second. But allocative efficiency is a little bit more narrow of a definition than productive efficiency. Productive efficiency, are you on the curve? Yes, you're producing in a productively efficient manner. If you're allocatively efficient, you have to be on the curve. We also need to know a little more information in terms of what society wants. So let me further explain using this. So it says, which points are productively efficient? For time's sake, I'm just gonna go ahead and do it. Which points are productively efficient? In other words, which points are we using all of our resources in production? A, B, C, and D. A, B, C, and D. Right? Not E, not F. Those are inefficient. G, we can't get there. A, B, C, and D represent productively efficient points. What about allocative efficiency? Well, we're producing bikes to computers. It would require a little bit more information. What if I said, this is a business that is located in a country that doesn't have electricity? All right? Would it be socially optimal to produce any sort of production of computers? No, it would not, right? If this country has zero electricity, what is socially optimal, what is allocatively efficient is A. That is it, right? There's no point in making a computer if there's no electricity. So one, it has to be on the curve, but two, it has to be meeting society's needs. So the only allocatively efficient level of output here, production, is A, if this country has no electricity, right? If this country does have electricity, I would probably argue it's B or C, would be allocative efficiency. Like if this wasn't written in the white, which points are allocatively efficient, I would probably argue B and C, because a society probably wants some bikes and society probably wants some level of computers, right? We don't want just one or the other. We want both, bikes and computers. But the whole point is, when you get a question about allocative efficiency, a little bit more information is required. If not, probably some sort of point that you're producing both, but it's on the curve. Okay, why two types of efficiency? If we're talking Nike, right? We're talking about Nike producing shoes, and they only produce two shoes, a size 10 running shoe and a size 20 running shoe. Would A be good, right? Would A be allocatively efficient? No, right? Nike should not be making size 19 running shoes, it looks like, because no one wears a size 19 running shoe besides Shaq, right? Shaq wears, I think, 22. He wears 22s, right? We looked that up one year, right? He has massive feet, but that's the idea, right? A goal of a business isn't just like produce an efficient manner. They need to know, like, what does society want? What is society's demand? Which we'll talk more about another time. All right, I'm gonna leave these MCs. You guys are gonna get a copy of these notes on the weekend. So if you guys want to use those MCs, you can. The last thing I'm gonna talk about in this little 10-minute span, and we put in some good work here, is what happens when the PPC shifts, right? What happens if we got to move the curve? In other words, what happens if we have a change in the amount of resources that we have, or we have a change in like technology or education or one of the factors of production, right? So here's the assumptions that we looked at. Let's change some things now, right? Let's say the resources are no longer fixed, and we find more oil, we find more electricity, we find more people, more labor. We advance our technology, right? Well, then obviously our curve is going to have to move. This right here is called an increase in productivity, right? Increase in productivity. An increase in efficiency would be like this. An inefficient point, if we have an increase in efficiency, we're moving to an efficient point. That's called an increase in efficiency. An increase in productivity means we are now capable of producing more. Our production possibilities now have increased. It has shifted to the right. We can produce more now because we have more resources. That is called an increase in productivity. I can't tell you how many students make that mistake, right? Productivity and efficiency sound like the same thing, probably how we would use it in everyday life, but in economics it's very specific. Productivity is the capability of producing something. Efficiency is how well we use the resources that we already have. Okay? So what does shift the curve? This is a big idea. Whenever we use a graph, people, we're always going to learn shifters of the curve. That's the point. We're going to learn why the curve looks the way it does, but then we're going to manipulate that curve in order to make generalizations, right? That's the idea. So we're always going to be moving the curve. Whenever there's an increase, we always illustrate that by shifting the curve to the right. So how can we ever increase or decrease that curve, that frontier? We'd have to find more or less resources, right? If we find more resources, that would shift it to the right. If we find less resources, it would shift it to the left. If we find more technology, it would shift it to the right. If we find less technology, it would shift it to the left. And then trade, but don't worry about that right now. We're going to talk about that next week. Right now, if we get more resources, more production. Less resources, less production. If we get more technology, more production. Less technology, less production. So let me give you 2 examples, and then I want you guys to try some of this on your own. What happens if there's an increase in population, right? So we're producing computers and pizza. If we have a bunch of people immigrate to the U.S., what's going to happen to our capability of producing computers and pizzas here in the U.S.? It's going to increase. So here's what I want you to do. What is the resource? Labor here, right? Is labor used as a resource in the production of computers? Yes, right? Is labor a resource used in the production of pizza? Yes, right? Well, if it's a resource and we have more of it and it's used to produce both goods, shift it to the right for both goods. This is how you would illustrate this scenario. What happens if there's an increase in population? We're going to be able to produce more pizzas and computers. Make sure you also draw an arrow, right? Now, obviously, I can't make you guys really draw graphs right now virtually, but if the AP test looks like it normally does in May, like it used to, you're going to have to draw graphs, all right? And you're going to have to use an arrow on your FRQ or else they're going to mark it wrong. You have to some way illustrate that this curve is a newer curve as a result of what happened here, okay? Let's do a different one here. What if there's a technological improvement in pizza ovens, right? So Domino's gets better pizza ovens, right? They buy better pizza ovens that are able to make pizza ovens faster, okay? Or they get pizza ovens that are able to make pizzas faster, okay? Are pizza ovens used in the production of computers? No, right? So we're not going to get any better at making computers. Are pizza ovens used in the production of pizzas? Yes, right? So we only got better at making pizzas. So how do I illustrate that change? It would look something like that. It would shift out to the right for pizzas. Okay? Cool. Okay. Sweet. All right. We're gonna skip this slide. I'm gonna make an audible right now. I think it's 4th down. I'm gonna punt. And I'm gonna make some changes to the playlist. I don't want to lecture this whole hour, and I want to be able to work with you guys for a little bit here. So here's what I want. Here's what I want us to do. I'm not gonna post problem set 1.2 today. We're gonna work on that on Monday. Okay, we're gonna work on that on Monday. On Monday, we're gonna do this instead. We're gonna reinforce what we learned the last 2 days because I feel like I'm going really fast. Monday, we're gonna play a little Kahoot. We're gonna work on 1.2 together in the Google Meet. And we're going to do maybe 20 minutes of lecture. Probably not even. Okay? That's our game plan for Monday. We're going to slow things down a little bit. So we're going to learn about Module 4 information on Tuesday. Mr. Moore's audible. We're getting out of that coverage, all right? Anyway, so here's what we're going to do during the Google Meet. I want you guys to write this down, right? So what you're going to do is you're going to draw 7 different graphs. Or 6 different graphs. 7 different graphs, okay? You're going to draw 7 different PPCs. Now, the PPCs don't have to look super elaborate, right? Just draw a vertical and a horizontal, label both axes, and then put a curve, and then draw an arrow wherever it goes. Or it might require you to draw a point with an arrow as well, right? Just somehow illustrate what is going on here in the white to your graph. And this is what we're going to work on during Google Meet, and this is what I want to check at the end, right? So make sure you have a loose sleeve sheet of paper during the Google Meet, okay? I hope you guys are picking this up. Oh no! Actually, blue you guys might struggle a little bit, but let's do it anyway, right? Let's kind of fail forward. Let's kind of struggle through it. All right. So 7 PPCs. It'd probably help to write, each one of these next to the PPC. Don't have one PPC with 7 different curves on it. One PPC curve, show what happens. New PPC, decrease in demand for pizza. Show how that is going to be illustrated in a graph. Okay? All right. I will see you guys in Google Meet at, like 12:02 or even 12:05 if you want a little bit longer break than usual, right? You know, go get some food, go get some drink, go to the bathroom if you got to use it. But I'll see you in Google Meet, and then I want to see you guys draw on 7 different graphs looking just like this. All right? All right, I'll see you guys in Google Meet here in, don't look at that, in a second. I had the answer.